sum. Yeah, let's try to first understand the problem. So we are giving an array nums, just with integers, and we are also giving a number k. So k is the window size. So this means, for example, we can choose 10, 2, and for the next number, we can either choose minus 10 or we can choose 5 directly. So for example, if we choose 5, because window size is 2, yeah, it means from this number 2, we can choose 5. So 10 plus 2 plus 5, it is 17, and then plus 20, it is 37, yeah. But from this number 2, we cannot choose 20 directly, yeah, because the window size is 2, and from 2 to 5, so the window size is 2, but 2 to 20, the window size is 3, yeah. So this problem is similar like the longest increasing subsequence problem. If you solve that problem in O(n) square, it is similar. So this means, so for example, we need to find a number. For example, this is 5, but we need to choose a window. The window size is 2. It means for this 5, we can choose 2 numbers. So for example, this minus 5 and this 2. But these 2 positions actually are not the number itself. It is inside the DP array. So for example, this number, yeah, let me just copy the array to explain it. It might be easier to understand. Yeah, let me put it here. So if we have a number like that, yeah, so for the array, the first number is gonna be 10, but the second number, if we use DP, it's gonna be 12. Yeah. Now we are going to calculate the third number. So from this minus 10. So what can be the maximum? We can choose this number, or we can ignore this number. Yeah. If we choose this number minus 10, so what can be, we can, yeah, so from this position, it can have two ways. We can directly use this number. If we choose this number, directly use it, it can be minus 10, yes. Or we can choose this number and previous maximum number. Yeah, and the previous maximum number with window size of 2, it is 12. So the maximum number is 2 instead of minus 10. Yeah. So what about the next one? So for this number 5, so what is the window size? It is 2. So for this 5, we can choose this number 2 or 12. Yeah. But we're gonna choose 12. So the result would be 17. So what about the next one? Yeah, it is 20. We can choose this 17 or this 2, but definitely we're gonna choose 17. It is 37. Yeah. So according to this kind of algorithm, if we don't use any kind of data structure, it's gonna be O(n) square, and n is the length of nums, 10 to the power of 5. So it will be time limit exceeded. So we're gonna choose some data structure to calculate the maximum number inside a window. So what kind of a data structure can calculate the maximum number inside a window? Of course, it is the monotonic queue. Yeah, and there is also another data structure which can be solved the maximum number inside a window. It is a balanced tree. But in Python, we can use the sorted list to solve such kind of problem. Yeah, so for example, if the window size is 2, we're going to calculate the maximum number. If we use the sorted list, we are sure it is in increasing order. The last number would be the maximum. We can choose this number directly. It is log n time. So the time complexity is n log n if we use the sorted list. But if we use monotonic in decreasing queue, we can get this number directly in O(n). So the time complexity is O(n) because we're gonna loop through the array and we're gonna use the monotonic queue to find the maximum number. Yeah. Now let me first try to use the sorted list to solve the problem. Yeah, let's try to use the n log n time to solve it. So from sorted containers, we need to import the sorted list. Yeah, because we're gonna use this kind of balanced train data structure to solve the problem. Yeah. So I'm gonna initiate the sorted list. So SL should be equal to the sorted list. Now I'm gonna prepare some variables. So L is the left index, and the result, I don't need to, let me check. I don't need to prepare the result because the result would be maximum of my DP array. So I'm gonna prepare two variables first. So L is index 0, the left index, and N is the length of nums. And I'm gonna prepare a DP array. So the DP array would be the nums 0 from the beginning times N. Yeah, because for my loop, I'm gonna start from index 1. So this is why I'm gonna first prepare the first number. Yeah, definitely inside of the DP array, the first number is nums 0. For example, here it is 10. Yeah. Now I'm going to loop through the array. So for R, let me use for R in range. Yeah, because I'm gonna start from index 1 to N. Yeah. First of all, I'm gonna use the DP. So for the DP array, the DPR should be equal to the maximum of nums R. So this means we only choose this number. So for example, from this number -10, we directly choose this number. Or, yeah, I think this should be very clear. If you solve a lot of DP problems, this is gonna be really clear. Yeah, if you want to choose the maximum number at this point, what you can do, you can choose this number directly, or you can choose this number with the previous maximum. Yeah, so we can choose nums R or nums R plus. Yeah, we need to plus a number which is the maximum number. So what is that number? That is inside the sorted list. So it is SL -1, because inside the sorted list, the last number gonna be the maximum number. Yeah. Now we're gonna put this number inside the sorted list. So it should be the DPR. Yeah. Yeah, we're gonna put all the DP arrays, DP numbers inside the sorted list, because the numbers inside the DP array is the accumulated sum. Yeah, is the accumulated maximum sum. Yeah. Now we need to check the length of the sliding window. So if R minus L plus 1 more than this window K. Yeah, it means, so for this example, if this K equal to 3, it is, yeah, if the window size is 3, it means it is more than the window size. We have to handle the, yeah, sliding window. So what we need to do, first of all, we need to take out the numbers. So SL need to remove the numbers. So what is that number? That is SL with the L pointer, and then the L pointer should plus equal to 1. Yeah. And finally, we just need to return the maximum of the DP array. Yeah. So I think this is the entire coding. Let me try to run it to check. There's something wrong. Yeah, let me check what is wrong. Yeah. Yeah, let me check. Here's something wrong. Yeah, because this number inside the sorted list, it can be a negative number. Yeah, so we need to choose. Yeah, I think I need to choose the maximum of 0 with this number. Yeah, but I'm not sure if it is totally okay. Yeah, inside the sorted list. Yeah, so here, let me explain this one. So from here, we need to choose the maximum, this sliding window with 0, because inside of the sliding window, it can be a negative number, because there's a negative number inside of the window. So we're gonna choose the 0 with the negative number. This means, yeah, at least we're gonna choose nums R. Yeah. And inside of the sorted list, for the first number, we need to put it inside. It's gonna be nums 0. Now let me run it to check. Yeah, there's still something wrong with the last testing case. Yeah, so this is my sorted list. This is L and N. This is my DP array. It should be maximum of nums R with nums R plus maximum of 0 with SL -1. Add to the DP. If it is more than K, it should remove this number. L should plus equal to to 1, and finally I'm gonna return the maximum of dp. I don't know why it is wrong. Yeah, 30. It should be, yeah, it should be 23. Yeah, it is 23, but for me I get 30. It means my window size is wrong. Yeah, otherwise I think the maximum gonna be yeah, gonna be 23. So how can it be 23? It's gonna be like 10 minus plus minus 2, yeah, and plus minus 5 and plus 20. It is 23. Yeah, we just ignore this number. Yeah, it means there's something wrong with my sliding window. Let me check it. If r minus l plus 1, yeah, I think it is coming from SL. Yeah, SL should remove the number. I think it is coming from here. It should be dpl instead of SL. Yeah, instead of SL. I don't know why I'm writing something like that. That is absolutely wrong, I believe. Yeah, it should be dpl because inside of the dp array, this is the L pointer. The window size, for example, this is the dp array, so the L pointer is here. We need to remove this number 10, for example. It should be dpl. Yeah. Now let me run it. Now as you can see, it works. Now let me delete those two lines and submit it to check if it works. Yeah, as you can see it works, but it's really slow because the time complexity is n log n. Yeah. Now let's try to optimize this time complexity to O(n). Yeah. If we were to use O(n) to solve the problem, we have to use the monotonic queue. Yeah, if we use monotonic queue, we will not use the sorted list. So I'm gonna, yeah, delete all this, delete the sorted list, and I don't need the L pointer. Let me just delete the L pointer. I just need a variable n and dp. Yeah, and finally I'm gonna return the maximum of the dp. Yeah, now let me just change, yeah, this areas to write a monotonic, I think monotonic decreasing queue to solve the problem. Yeah. So what are we gonna do? We're gonna prepare a queue. This queue gonna be a monotonic queue. Yeah, so I'm gonna put the queue inside. So the first index gonna be 0 because I'm gonna use the index inside of the monotonic queue, and then I'm gonna start from the second index. It is index 1. Yeah. So for r in range 1 to n, first of all I'm gonna check this queue while queue and the count number. So what is the count number? It is dp. Yeah, so before that I need to calculate the dp. Similarly, it's like before. I have to check what is the maximum of the dpr. So the dpr would be the maximum of, similarly it's the same nums r with the maximum of 0 with nums r plus, yeah, let me check, nums r plus the, yeah, it is a dp array, and yeah, I need to find a value inside of the queue. Yeah, it should be inside of the queue. It is the index. I need to use the index, so it should be dp with q minus 1. So q minus 1, let me check, it should be q0 because I'm gonna use the monotonic decreasing queue. So the first number at the front of the queue, the first number gonna be the maximum. So this q0 is the maximum index, and for dp with this maximum index I got the maximum number, so the nums r should plus this number. But yeah, it needed to check with this 0. If it is a negative number, I'm gonna choose 0, and then I'm gonna check this nums r. It can be more than 0, yeah, or it can be a negative number, yeah, but the final result should be at least 0. So this is why here I used a 0, yeah, from here. Now let me try to use the sliding window for the monotonic decreasing queue. So this dp r currently my current number is, yeah, if it is decreasing, I need to check if it is more than that. If it is yeah, if this number is more than the number at the end of the queue, I need to pop out. Otherwise, I need to append. Yeah, if it is dpr more than dp with the last number at the end of the queue, it should be q with -1. Yeah, so q should pop at the right side, and after that q should append the index r. Yeah, now I've finished the window. So this is the monotonic queue. This is a window size. I need to keep this kind of window, and I want to keep a monotonic decreasing queue. Yeah, now I need to check the window size. So if the window size is more than k, so if r minus, so what is the window size? It is the q0, right? Yeah, +1. If it is more than k, so q should pop from the left side. Yeah. So finally, I just needed to return the maximum of dp. As you can see, it is similar, but only the differences from the monotonic queue data structure. Yeah, only use a few lines, like 4 or 5 lines, you can totally change the time complexity from n log n to O(n) time. So that is why this monotonic queue data structure is so powerful for solving the sliding window problem. Yeah. Now let me run it to check. It seems that something is still wrong for the second testing case. So for this k equal to 1, I got a 0, but it should be -1. Yeah, it should be -1, but I got a 0. It means something wrong with it. Yeah, let me check. Do I need to? Yeah, must be non-empty. Yeah, if I get a 0, it means it is empty. It must be non-empty. So we choose the largest number. Yeah, let me check. How can I fix this kind of a bug? Then q should pop from the left side while q and this is more than, and I need to take this number. It's gonna be the maximum. Yeah, let me just delete this 0 to check if it is okay. Yeah, if I delete this 0, it seems that it is okay. I don't need to get the maximum number with 0. Yeah, because for each of the time, I can choose this number directly or this number with the previous maximum number. Yeah, I think it should be okay. Now let me run it to check. I don't need to get a 0, otherwise it's gonna be wrong, because I need to choose at least one number inside the array. As you can see, it's really fast than before. Yeah, now let's go back to check the sorted list solution. Why in the sorted list I need such kind of 0, but here I didn't even need it. Yeah, let me try to find the solution for the sorted list. Yeah, let me copy the code from the sorted list. I'll try to understand why from here actually we don't need it. Yeah, now let me first run this code to check. Yeah, because here for this solution, basically I compared it with the maximum 0 with this one. Yeah, as you can see it. Yeah. Now let me go back to this solution to check why it is wrong. Oh, I can't find it, but yeah, if I choose the maximum from here, it should be okay. Maximum 0 with dp. Yeah, let me try to choose this one. I think it should be okay. Yeah. So yeah, for this kind of solution, let me just yeah, choose the maximum with this. Yeah, I'm not sure. I don't think I needed to compare with this one. Yeah, it should be. Oh, I deleted more unnecessary things. Let me delete from here. Delete this one. Yeah, let me run it. Yeah, as you can see, it works. I choose a maximum number with this 0 with dp inside the dp with q0 inside the monotonic q with this dp. It means yeah, I can choose this number. If this number is a negative number, I'm gonna choose 0. It means I will not choose it. Actually, I don't need to write this line. It is totally okay. Yeah, let me submit it first. Yeah, as you can see, it works. Yeah, but we don't need to check with the maximum with 0 with this number. Yeah, we can directly use the nums r plus the previous number. It is totally okay, because if it is less than nums r, so I'm gonna choose this nums r. Yeah, if it is bigger than nums r, I'm gonna choose this one. So this is why it works. Yeah, as you can see, it works, and it's much faster than before. Thank you for watching.